So we ended class looking at example 3. We were able to approximate the change in P given a change in pressure and a change in temperature. We can also use differentials here to estimate maximum error, and that's what they want us to do in the next example. Maximum error in measuring V if the pressure is 2 kilopascals plus or minus 2% and the temperature is 350 degrees plus or minus 2%. I'm sorry, plus or minus 1%. So our error here is actually the absolute value of the change in volume. So could be positive or negative. We're just going to look at absolute error. And this can be approximated by the absolute value of dV. Well, we know what dV is. It's right here. So we can put that expression inside the absolute values. So this will be negative 8.31 times t, and then I'm going to divide by p squared. So instead of using a negative exponent, and then plus 8.31, divide by p. So again, bring this down as a positive, and then dt. And then next, I'm going to overestimate this to make things easier. So I'm going to use a property of absolute values. The absolute value of the sum, a plus b, is always less than or equal to absolute a plus absolute b. And then I'm also going to use the fact that the absolute value of a product, ab, is absolute a, absolute b. So you can break products apart with absolute value. And they're still equal. Same thing with quotients. So I'm going to say, well, this is less than or equal to absolute value negative 8.31 t over p squared times absolute value of, whoops, I forgot a dp in here. Absolute value of dp plus absolute value of 8.31 p over p, and then absolute value of dt. So I first did this, so I did this, made it bigger, and then I broke the two products apart. So I did two steps in one here. And then this absolute value, well, the negative 8.31 will change to a positive. And then temperature and pressure are always positive. So we don't need absolute values around them. And then absolute value of dP, so that's the change in P. So this is plus or minus 1%. That is telling us that dP is going to be plus or minus 0.01 times 2, which is plus or minus 0.02 Pascal. And then we'll do the same thing here for temperature while we're at it. So the plus or minus 2% is going to be, it's going to be telling us that dt is plus or minus 0.02 of the 350. And that's actually plus or minus 7 degrees. So these guys are positive, and then we need to leave our absolute dP inside absolute values, and then these are both positive, so we can drop absolute value, 8.31 over p, and then we'll leave that inside the absolute value. So dt. So now we can go ahead and plug in our T and P. So P is 2 and T is 350. So this will be 8.31 times 350. And we're dividing by 2 squared. And then our dP is plus or minus 0.02 Pascal. So this will be absolute value of plus or minus 0.02. And that's just going to be 0.02. And then the next term, 8.31 divide by P is 2. And then our absolute value of dt, so the change in temperature is 2% or 7 degrees. So absolute value plus or minus 7, which is just 7. And then plug all these guys into the calculator using the 0.02 and the 7, and you will get approximately 43.6, and that is going to be volume. So this would be liters. So that's our maximum error. So we're getting quite a large error there for just a 2% error in temperature and a 1% error in volume.